So the topic about design of welded joints under eccentric loading condition we discussed in a class in the last class. So based on the few problems we are going to discuss today. Here a welded joint is shown in figure is subjected to eccentric load of 2 kilonewtons. Here it is subjecting 2 kilonewtons. Find the size of the weld if the maximum shear stress is 25 megapascal. So given data is load is given 2 kilonewtons, that is 2 into 10 to the power of 3, and maximum shear stress 25 megapascal. What is asking here? Size of the weld, how much? Okay, so this is the problem in eccentric loading condition. In eccentric loading condition, we have two cases. Case 1, case 2. So case 1 is belongs to this type of diagram. Means the diagram will appear in a cantilever beam shape. So this is the one plate. Another plate is welded perpendicular to the previous plate, and welding is done here. Okay. Now, as per the case 1 procedure, in case 1, this type of joint is subjected to the two different type of stresses. What are those? First thing is a direct stress, otherwise primary shear stress. Second one is the bending stress. This bending stress is due to eccentric loading. Okay, so because at, at a time two simultaneous forces are stresses are acting on a particular element, so we are adapting the theories of failure here. So we have two theories of failure. First one, the maximum principal stress theory. Maximum stress equal bending stress by 2 plus 1 by 2 into bending stress square plus 4 shear square. The next theory is maximum shear stress theory equal 1 by 2 into square root of bending square plus 4 shear square. These two theories we are adapting here because on this particular element at that time two different in nature stresses are acting. Okay, and again here which theory of failure we need to consider here. So see here, read the question properly. Maximum shear stress in the weld is 25 megapascal is given. So maximum shear stress. It means this shear stress theory we need to consider for this problem because this maximum shear stress value is given in the question as a 25 megapascal. So that reason this equation I'm selecting. Okay. So in this equation, what parameters required? We required sigma b and we required shear stress. So this shear stress is known as here direct primary shear stress. Sigma b is known as bending stress due to eccentric loading. So now I'm calculating shear stress. What is the equation, general equation for stress load by area? So how much load is given in the question? 2 into 10 to the power of 3. Now what is the area? The failure area we need to consider. What is the failure area here? 2 into T into L. So what is T? Throat thickness. Already we did in the previous class. 2 into, in place of T, I'm writing 0.707 into S into L. Okay. Now 2 into 10 to the power of 3 into sir. Hello. Now here into L. So 2 into 0.707 into S into what is L? L is nothing but length of the weld. This is the length of the weld. Length of the weld. The length of the weld is equal to the width of the beam, 40. So here I'm writing 40 mm. Now what is the value? Tell me the answer. The answer should be in terms of yes, megapascal. Tell me the first. How much, Babu? 35.4 megapascal by S. So this is the primary shear stress. Now what is the secondary shear stress? So not secondary stress. What is that? Bending stress. So to calculate bending stress equal M by Z. So M means load into distance. That is this M I'm calculating. Load into distance. That is 2 into 10 to the power of 3 into E value how much given in the question. This 120 mm is nothing but E. Okay. So E value 120. Now what is Z? Z is a section modulus. Okay. The section modulus values we need to take from the table. So this table, see here. These are the cross sectional given in the table. According to the cross section, we need to select the values. So at the title here, section modulus at the top, we can find the title section modulus Z, polar momentum of inertia J. So here, what type of cross section we can find? The fourth type of cross section we can find for the diagram. This fourth type of cross section we can find. So that is here TB square by 3. So this one already we derived the derivation. Okay. So the derivation part I'm writing here. S into L square by 4.242. This particularly this one we derived in the previous topic. Okay. So this is a section modulus. So S into 40 square by 4.242. So if you substitute the all values in this sigma b equation, then sigma b value will get 636.5 by S megapascal. So sigma S, sigma B we calculated. Now as per maximum shear stress theory, what is the equation? 1 by 2 into square root of sigma B square plus 4 shear square. So this much, how much given this value? The value is given in the question as 25 megapascal equal 1 by 2 into square root of 636.5 by S square plus 4 into shear value, how much we got? Shear value 35.4, 35.4 by S square. Now with this equation, we are calculating S value. How much the S value here? 12.8 mm. Okay. So for this respective diagram, for this kind of load, how much size of the weld we have to maintain? The size of the weld we have to maintain 12.8. Okay, is it clear, Babu? Shall we move to next problem? So this is the another type of problem. A 50 diameter solid shaft is there. This shaft diameter is given 50 is welded to a flat plate as shown in figure. If the size of the weld is 15 if the size of the weld is given here 15 find the maximum normal and shear stress. Maximum stress how much and maximum shear stress how much? Question is asking. Okay. So load, how much given load here? P is given here 10 into 10 to the power of 3 newtons. Eccentricity value is given here 200 and where T is the throat thickness, S is the size of the weld that is given in the question 15 Okay. So for this type of problem, in previous problem, this shear stress value is given and asked to calculate S value how much. In this problem, S value is given and asking to calculate stress is how much. Okay, it means same equation we have to write. What is the maximum principal stress theory equation? Bending stress by 2 plus 1 by 2 square root of bending stress square plus 4 shear square. What is maximum shear stress theory equation? 1 by 2 into square root of sigma b square plus 4 shear square. Okay, same equation we are using. Instead of calculating S value, we are calculating the maximum stress S value. Okay, so for this first one, what to calculate this value, what parameters we required? We required this shear stress value, bending stress value. Shear stress value is nothing but primary shear stress, that is load by area. Load how much given? 10 into 10 to the power of 3. Area is how much for this figure? So for this figure, area don't write pi by 4 into d1 minus d2. If you open this one, if you open the this black color welded portion, it will form a long rectangle like a kind of ribbon. Okay, so this is the nothing but length of the weld, and this is the throat thickness. Okay, Babu. So if we open this one long rectangle, what is the length of this one? Pi into d, that is equal length, and this is the thickness, throat thickness. I'm opening this black color welded portion now. This hair shaded portion I'm opening here. So now we can easily calculate the area. The failure area is, for this figure, area is pi d into t. So d is the diameter of the rod, t is the throat thickness. Okay. Now pi into d value how much given in the question? D value 50 diameter. So here write the D value 50 So 50 into throat thickness, how much? 0.707 into S. Okay, that write the A value here. Pi into 50 into 0.707 into S. Okay, now what is the primary shear stress value? Primary shear stress value is 6 megapascal. Now bending stress we need to calculate. Bending stress is M by Z. Z value how much? The Z value is we have to take from the table. See this table Z value pi t into d square. So this kind of shape is appearing in the question. The cross section of the welded portion. This is the okay. Now this is the throat thickness, this is the size of the weld, and throat thickness and diameter. So for this figure, the section more or less is pi d square into t by 4. Okay, that I am writing here. Section more or less value is pi into d square into t by 4. And what is m? Bending moment. How much bending moment? This force into perpendicular distance. 10 into 10 to the power of 3 into 200. How much this one? Sigma b value 96 megapascal. So both value we calculated. Just substitute in the equations. First one, as per maximum principal stress theory, stress theory. What is the equation? Maximum stress equal bending square by 2 plus 1 by 2 into square root of bending square plus 4 shear square. So bending square, how much we got? 96 by 2 plus 1 by 2 into square root of 96 square plus 4 into shear stress value, how much we got? 6 square. If we simplify this problem, the final answer will come 96.4 megapascal. That is maximum stress. Now, as per maximum shear stress theory, maximum shear stress theory, maximum shear stress equal 1 by 2 into square root of sigma b plus 4 shear square. So 1 by 2 into sigma b square, how much? 96 square plus 4 into 6 square. If you simplify, what is the answer? This one 48.4 megapascal. Okay, this is another type of problem. Means in previous problem, maximum limit is given, permissible limit is given, asking to calculate size of the weld. Here in this type of problem, size of the weld is given, asking to calculate maximum stresses. Okay, any doubt regarding this problem over? Shall we move to next problem? Yes, tell me over. Shall we move to next problem, or you're going to join the webinar? So time is 10:50.